Good day, everyone. And today, I'm going to present some of the outputs from our project entitled Solid Waste Analysis and Quantification, a planning tool for sustainable urban waste management in Butuan City, Philippines. Now, my co-author for this research is Ms. Jessa O. Aquino, an environmental planner and university research associate in UPLB-INREM. Now, this research is a component of the Waste Analysis and Characterization Study funded by the Butuan LGU and was implemented in partnership with the Caraga State University last 2019. This research tried to determine the per capita waste generation of the urban households in Butuan City, and also tried to identify the types of waste generated by the different sectors in a per capita basis. Now, the basic information was then utilized to propose strategic interventions and probably develop a working framework or model for urban solid waste management. Now, my presentation will follow this outline. First, I will begin by presenting the rationale of the study, followed by the methods used in data gathering and analysis. And the results of the study will also be discussed briefly. Now, the remaining slides will be for conclusions and recommendations. So let's begin. Now, according to the World Bank, urban centers and highly urbanized cities in developing countries are characterized mainly by agglomeration of economic activities and institutions. Now, this was primarily due to the increases in population coupled with increasing demand for and consumption of resources. And this has direct implications to urban metabolism. Now, with that set up, issues pertaining to solid waste generation and management are gradually emerging in urban areas. In fact, a city generates approximately 95 tons of solid waste on a daily basis. It was also projected that urban agglomeration in the Philippines would reach 102 million population. So this corresponds to 65% of our total population residing in cities and urban centers by the year 2050. And one could really imagine the scale of socioeconomic and environmental issues on waste management if this will not be addressed strategically. Now, it is for this reason that there's a need to conduct waste analysis and quantification to strategically formulate SWM-related policies and PPAs in compliance with RA 9003 provisions. And this study was geared towards the provision of baseline information geared towards the strategic SWM planning in local level. Now, this is a 2D map of our study site. So Butuan City is located in the northeastern part of Mindanao. It is a highly urbanized city comprising of 86 barangays, 44 of which are urban and 42 are rural barangays. Now, the city is also the economic and administrative capital of Caraga region with an era of 2.74 billion, so having an economic growth rate of 6.5%. Now, the industries dominating the cities are mostly wood-based, agro-industrial, and the service sector. Now, this increasing population pegged at 1.65 growth rate, and this could lead to high demand for services and resources, which will later on translate to an increase of generated solid waste. Now, the green areas in the map represents the 44 urban and urbanizing barangays covered in this research study. Now, similar to other highly urbanized cities and urban centers, a considerable volume of solid waste were generated and disposed of inappropriately in the entire city. And this type of scenario was actually observed in their coastal areas, urban barangays, and even in its final disposal facility located in Barangay Dumalagan. Now, this indicates that for the urban communities of Butuan City, solid waste management is gradually emerging, not only as an environmental issue, but a public health and a behavioral concern as well. Now, for this research, we developed survey questionnaires and conducted household and non-household surveys. And for that, we calculated the number of samples using a two-stage random sampling design to determine the number of household samples for each of the 44 urban barangays. Now, a total of 427 samples were calculated to participate in the survey. And it was distributed proportionally to the 44 barangays using the sample size formula for estimating proportions. Now, the number of establishments and public markets per classification were provided by the City Planning and Development Coordinator's Office. And working on that data, we used the two-stage random design formula, and the number of samples for the non-households and public market surveys were calculated. So we have a total of 362 samples for non-households and a total of 148 samples for public market establishments. Now, in estimating the total amount of waste generated by the households and non-households on a daily basis, a general formula was used. So we have the total waste in kilograms per day as equal to the total population multiplied by the amount of waste generated per capita per day. And we utilized the linear regression equation using the city's urban population data from 1970 to 2015 in order to determine the 10-year projected household population, where a population T or PT as a population of the last census, B as the average growth increment per unit time, and N as the unit of projection. And lastly, to calculate the projected population for non-household sectors, the growth rate was integrated as multiplier in the equation. Now, for the implementation of survey and baselining activities, some considerations were established. So the survey and data collection were designed for 5 consecutive days for both households and non-households and public market establishments. Now, the only difference is on the cover days. So for household, data collection was conducted during ordinary days, a market day, and a weekend. So while for non-households, we covered the weekdays and a weekend. And for public market establishments, data collection was done during weekdays, market day, and a weekend. We also conducted end-of-pipe measurements. And for this activity, the recommended sample was the whole truckload of waste for final disposal in the sanitary landfill. And all the waste materials collected in one truck, whether it is full or not, were sorted, measured, and weighed. Now, to ensure that waste samples were homogeneous, one truckload per distinct routes and collection schedule were selected, and the mixture of waste collected were characterized and weighed. So the process of weighing and characterization were all conducted for a period of 3 days. Now, as for the results, in terms of solid waste generation, a total of 174,714 kilograms of waste was generated from the urban communities of Butuan City across all sectors daily. So this translates to 59.2% of waste from commercial establishment, 39.2% from households, 1% from institutions, and 0.6% generated from the different industries. Now, this trend of solid waste generation is very common due to increasing urban metabolism caused by high population and demands for goods and services. So meanwhile, in terms of waste composition, most of the waste generated were biodegradable waste, accounting for 54% of the total waste generated, so indicating a wastage of food resources and the release of methane. Now, residual waste account for 22% and recyclables account for 16% of the total waste, indicating potential source of income. And lastly, special waste account for 8% of the total waste. So these findings really reflect similar patterns to the national solid waste composition of the Philippines, as reported by DNR-EMB in 2014. Now, comparing Butuan City's per capita waste generation with the national average, it was almost similar. And the estimated mean generated waste per capita per day reached 0.64 kilograms per capita per day. So this value was within the synthesized waste generation rate for highly urbanized cities in the Philippines, which is 0.69 kilograms per capita per day. So this indicates that waste management strategies and programs were either lacking, ineffective, and inefficient in terms of implementation in the community level. So with this, it can be assumed that the high per capita waste generation of the city would shorten the lifespan of its sanitary landfill in Barangay Dumalagan. So therefore, adjustment in terms of monitoring, capacity expansion, upgrading of SWM infrastructure, financing, and other related policies must be explored. Now, based on the figure, the waste generation projection revealed 100% increase, or approximately 354,953 kilograms of solid waste will be generated by all sectors within a decade or within 10 years. Now, this scenario could be the result of unregulated urban development and poorly planned SWM systems, which could result to problems related to public health, sanitation, and environmental degradation. Now, in major cities, improper management of solid waste resulted to urban flooding, damages to different types of infrastructures, and flooding of natural or man-made waterways during extreme weather events. Now, the projection also revealed implications on the current capacity of the 6-hectare sanitary landfill facility in Barangay Dumalagan. So approximately 3.91 hectares of land per year must be allocated to accommodate such volume of waste. Now, the current trend of urbanization and waste generation in Butuan City provided opportunities for development and the efficient and integrated approach resolving current and future SWM concerns. So therefore, a combination of technology, stakeholder engagement, economic interventions, capacity building, and policy adjustment must be prioritized to enhance the city's existing SWM system. Now, an integrated solid waste management system, or ISWM, could serve as a flexible framework to guide decision makers on prioritizing appropriate SWM programs and policies related to waste segregation, recycling, landfilling, and energy conversion. Now, an ISWM facility with a 500-ton per day capacity could be explored for the processing of all types of waste, particularly on the conversion of residual and special waste into refuse-derived fuel or RDF pellets. So this will be used by different industries and could generate high revenue and extend the lifespan of the city's sanitary landfill. Now, investments for clustered composting and materials recovery facilities could also be established strategically to resolve concerns on land availability in the urban barangays. Now, facilities for SWM could also be upgraded through procurement of additional SWM equipment and capacities. Livelihood opportunities and incentives that could facilitate behavioral change and community involvement must also be prioritized. And lastly, policies related to waste segregation at source, recycling, segregated collection, and waste conversion must be enacted and strictly implemented. And now for the conclusions. The conduct of waste analysis and quantification provided disaggregated estimations on per capita solid waste generation, identified the waste generators and the types of waste generated. And the commercial establishments and urban households generated most of the solid waste, followed by institutions and industries. The generated waste were comprised mostly of biodegradables, residuals, recyclables, and special waste. Now, the urban communities in Butuan City generated an estimated 174,714 kilograms of solid waste from its household and non-household sources, and that translates to a 0.64 kilograms per capita per day generated solid waste. And lastly, 100% increase in waste generation is expected in the next 10 years. So therefore, SWM investment and efficient interventions, especially on integrated solid waste management system, policies, and additional projects and programs must be prioritized. And that ends my presentation. Here are the list of my references if you want to check it. And thank you very much for listening.